Okay, so this is 11 p.m. I would like to start this week's tutorial live for Houdini. Hello, this is Junichiro Horikawa, and this is the 91st episode for Houdini Algorithmic live tutorial, which I'm been doing weekly. I couldn't do it last week though. Sorry for that. So this week's topic is to create kind of a skeleton of a sea urchin, which I found it really astonishing looking at the images. Something like these one, or all of these stuff. Seems like these are a skeleton bones of a sea urchin, which I didn't really know too recently. And I really like this shape, so I wanted to make something like these procedurally to see if I can do it. And turns out if you made a little observation to this image, you can see some patterns or rules in order to recreate these shapes. It's pretty based on some simple rule, I think, here. So that's what I'm going to tell you, and that's what I'm going to show you today, how I found out, or how I take the features out of this urchin model or urchin image as a procedural element. Okay, and the result, or the one that I'm going to create today as a result, is looking like these, with bunch of parameters. Like right now this is a bit more regularized shape, but could also be more randomish like these. You could also change like how many cells you want to have by changing parameters and so on. And you can also change the openings on the end. You could also make an ellipsoid shape as well from this one, which I haven't implemented as a parameter for this one, but maybe I can do it on live. As well as these seam or split lines in between those cells, which is also visible right here, these lines. So these are the things that I'm going to implement today from scratch. Hello everybody. Right. This is just to have fun. Okay, so first thing first, I'm going to observe this image, to see what's the role behind this thing. Okay, so first thing I notice is that the way the cell has been aligned next to each other, you see those small ridge line edges here, which seems to create this regularized cell shape, which you could see it similar to this centroid Voronoi tessellation, something like these one. Meaning you could imagine that you could use a Voronoi fracture to create this kind of cell shape if the point is at the right position, at the regular positions. There's also some pattern which have random, which has those cells and the random positions. Something like these is a bit randomish in terms of the positions, or maybe this is a bit too regularized, or maybe something like these. This is a bit more randomish in terms of the position of the cells, or these. So I think it might be interesting to be able to have an option to make the cell position randomish. And since I'm considering to use Voronoi tessellations, it's pretty easy to make it randomish just by moving point position randomly, and that's all you need to do. Or you could also, if you want to have like a kind of a centroid Voronoi tessellations feelings, even though if it's randomish, then you could use the remeshed geometry with the smooth iterations turned on as a base mesh, which will give you pretty much what you would like to see as a clean centroid Voronoidal Voronoi tessellation like feelings. Okay, so that's what I'm gonna do as a base. And in order to create the center line or the split lines like these, looks a bit tricky because these lines are not seems to be based on those cell shape, but it's looks a bit independent with these lines. And I assume that these lines are a result of the growth of the skeleton. So what I imagined is, first of all, you had these orange peel like shape, which has these cells is initially, and when it grows there seems to be some additional strip in between some of the cells. And making it widened out to create some kind of ellipsoid shape. Okay, so that's what I assume. So maybe initially it was like a sphere shape with all surface being covered by the cells, but then at some point it grows out, and to have this in between or some spaces between the cells to make it bigger. So I'm gonna try to implement these strips just like it's going to by making the space between the original cells. So first I'm going to create a sphere together with those cells on top of it, then split those cells with these in spacers to make it grow, to widen on XY plane or XZ plane, XZ direction or the plane direction. So that's my plan, and in order to create these how do I call this, like small mountain like shape to each of the cells, it should be pretty easy to do. I'm going to get each of the cells shape, then smoothen out the outline to create the 2D profile first, then raise up the profile using some kind of a maybe a ramp parameter so that you can control the shape by yourself, and and move it to the normal direction. Then you'll be able to create this kind of a mountain, custom shaped mountain. Then for those small particles or small spheres, I could just set some densities around the cells and just copy the spheres on top of these point positions. So it's just a matter of setting the density value. For the strip, doesn't seem like there's any spheres on top of it, but instead it looks like these are holes here. But it's gonna be a bit messy to make a hole for my setup because I want to make it simple. So I'm just going to copy the same spheres on top of the strip with some gradient value, similar to what I'm going to do with the age of the cells. So that's my plan, and that's what I'm gonna do today. Okay, so let's do this and from scratch. Okay, so the first thing I would like to do is to create a sphere shape with the top and bottom open up a little bit, just like these. So on top and the bottom you have some holes or maybe some other geometries, but I'm just gonna make it as a hole. It says it's mouth. Interesting. I'm just gonna make it opened. So I'm just gonna assume that we're going to see the shape from the side view. Okay, so first thing first, you can create the sphere in any way, but since I would like to make a hole on top and the bottom, I'm going to start by creating a line and then make it as an arc shape. Trim the arc shape to and revolve it to create a sphere first of all. Okay, so let's set the number of points to 50 so that I have enough points to make it as an smooth arc. Okay, then I'm going to use the point wrangle to change the shape of this line to a arc. Okay, so since the arc shape is just a half of the circle, it's a pi as an angle in total. So first of all, I'm going to get the point number and convert it into a value in between 0 to 1 for from start point to the end point. Name it f and get the point number divided by the total number of points, which is n points. And divide it like this so that you will get a value in between 0 to 1. Alright, now I am now going to calculate the angle, which is in total pi, and multiply by f, you'll get a value in between 0 to pi for each point. Then you can use the trigonometry to calculate the position for x and y in order to create an arc shape. So for x value, you can use a sine function with an angle, and for the y value, you can use cosine, and then by setting the x and y to a point position, you can create an arc shape like this with the radius is equal to 1. Right. That's good. Now, and what I want to do now is to create some offset to this arc so that I can trim out the starting point and the end point right here. Okay, so let's create a additional parameter for this one, which could be in between 0 to 1 again. Float offset. So if it's 0, there's no trim. If it's more than 0, then I want to trim out these curves for the top and the bottom. Okay, so in order to do that, what I could do is I could remap this f value so that it's in between the offset to 1 minus offset. So which means f is equal to fit 0, 1 f offset 1 1 minus offset. Okay, and also let's bring the angle right after I recalculated the f value, and now you get a trimmed arc. Alright, seems to work. So if it's 0.5, then it just disappears. So maybe you can set the maximum of this offset as 0.5. Okay, so I'm gonna keep it as 0.1 for now. And let's have a null node. And to have all the parameters that I can control to change the geometry, change the shape of the geometry. So I'm gonna bring this up, the first parameter. Okay, so that I can control it right here. Okay, great. Okay, now next thing I would like to do is to create the revolved shape to make it as a sphere-like shape, which has a hole on top and the bottom. Okay, and in order to when I'm doing that, I would like to use these point as a actual point position for the cell for Voronoi fractures. So right now there are a bit too much point right now. So I'm gonna reduce the number of points by using resample first. And instead of using maximum segment lengths, I'm gonna use maximum segments so that I can choose the number of points to use. Okay, and this could be another parameter, I think. So let's have this. Alright, going in back to a controller. Drag and drop the segments, and let's call this, how do I call this? Horizontal div. Or is it horizontal divs? Looks more like vertical divisions, is it? Vertical. Wait a minute. Yeah, vertical divisions. Vertical divs. From 1 to 50 is fine, I think, for now. Okay, now I can control how many points that I would like to use for vertically. Now, let's try to revolve this. In order to do that, what I'm gonna use is revolve to create a revolutional shape. 360 degrees is fine, and there's another divisions you can control, which is for horizontal divisions. And I don't need to show the UV, so I'm just gonna hide it. Okay, so this could be another parameter. Let's go back to the controller again. Bring up the divisions, and I'm gonna call this horizontal divs. 150 is fine. Alright. Okay, now let's check. Okay, so the next thing I'd like to do is in order to create a Voronoi tessellation, something like this, what you would want is to offset the point with half the distance of this distance. So by moving this point in between these points, you'll be able to get this kind of zigzag shape, just like I would like to do, like this one. Okay, so in order to do that, I think moving the odd number or even number of these lines or vertical lines to downward or upward by the half distance of this edge would make sense to create a zigzag shape as a to use these points as a base, the center of the Voronoi. Okay, so to do that, I need to pick those points which is on the odd number or even number. In this case, if I choose this one, then next point that I would need to choose is this one, and this one, and this one, and so on, and move it downward or upward by the half lengths, and not moving, maybe rotating by the half lengths of these edge, or half angle between this point and this point. Okay, so that's what I would like to do, and in order to do that, I need to look at the point number and see how I can get those informations by using the information like vertical divisions and horizontal divisions. Okay, so let's see. So the point counted from 0 and right here. So 0 goes like this, 0, 1, 2, 3, 4, create one layer, and then go back to somewhere around here, or here. Where is it? Yeah, right here, and goes right like this. So there seems to be a rule, and for each layer you have in right now 15 points, which corresponds to this horizontal divisions, and for vertical points you have in total in this case 1, 2, 3, 4, 5, and it is equal to this value plus 1. Okay, so we could use those information to assume which one is at the odd number or even number in terms of these circle. So what we want to do is to pick, if I pick this one, then we want to pick this one, this one, this one, this one, this one, this one, and this one. Now the problem is, if I in this case the total number of the points here is a odd number, which means if I just pick this one and goes around the circle by picking up just the even number, stepping by 2, skipping by 2 points, then at the end you have point next to each other picked up. So that's a problem. So in order to avoid that, you always need to have this horizontal divisions equal to even number. This cannot be a odd number as a parameter. So let's see if I can do that with the controller. I'm not sure if I could do that. If I could if I could restrict it to only to a odd number or even number, maybe not. So instead of setting right here, I'm gonna create some expressions to make it as a even number somewhere. So let's say I have something like 5. Right now I have obviously odd number as a total number of the circle or this polygon for each layers, but I want to make it as a even number, so maybe 6 or 4, either way. So in order to change that, first let's go back to where we are using this horizontal divisions, which is this one, resolve, right here. And what you just need to do is to this is 5 right now, so in order to make it even number in order to make it always a even number, you can just add a same value with the remains calculated. So if this is a odd number, you always get 1. If it's even number, you always get 0. If you calculate the remains by 2, modulus of 2. So as a result, you should always get a even number as a result, because you are adding 1 when it's even number, and by adding 1 to a even number you get by adding 1 to a odd number you always get the even number. Okay, so that's a little trick here. So this should always give you a even number for the layers. Now right after doing that, now I am ready to shift the point positions upward or downward for the even number of these vertical lines. So first we need to pick those lines, and then I am going to do that by using point wrangle as always. And let's show up the point number so that we could imagine what kind of information we need to use. So obviously we have two important information. One is the vertical divisions and one is the horizontal divisions. How do I name this? vdiv. I'm gonna create it as a parameter. Right. Now I can directly copy this directional divisions to this one. For horizontal divisions, we have changed the value a little bit inside this expressions. This resolves, so I'm going to copy this one instead and paste it right here to use it. Okay, so we have now 11 for vertical divisions, 18 for horizontal divisions. Okay. Now, first thing I would like to get is the ID number for a horizontal layers or horizontal curve. In this case, a circle. So for each circle layers, I would like to calculate, or I would like to create an ID starting from 0 to some value. So if it's 0, then this becomes 1, 2, 3, 4, 5, and goes back to the end. Same for all the other layers, sharing the same ID for a same vertical line. So let's do that by showing up the points first and let's see what's the rule here. So this one starts from 0, 1, 2 and end at 17, which corresponds to this one. So I can imagine that the ID, let's call this HID, horizontal ID, can be calculated by the point number. Yeah, and calculate the modulus, calculate the remains by dividing by H division. Okay, and let's see if I got the right value. I'm going to attach this to an HID attribute, integer attribute, visualize this as a text, see if I get the right value. Okay, so 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. You see that a certain vertical line shares the same horizontal ID for each curves. So looks good. Let's do the same things for the vertical. Let's create the vertical ID now. So maybe starting from this here. This whole layer can share the value 0, The second layer could share the value 1. Third layer could be 2, and so on. In order to do that, let's see how I can do that. In order to do that, you could use the same point number, but instead of calculating the remains, you can just divide it by the h divisions. Make sure this is a float, and calculate the floor. And as a result, let's see, I'm gonna show up another ID here, VID, VID. And yeah, looks good. Starting from 0 at the top, 1 and the second layer, 2 and the third layer, 3 and the fourth layer, and so on. Seems to work. Now we can use these informations for what we want to do. The things that I want to do here is to shift the even number of these lines to upward or downward by the half angle in between this point and this point. Now each edges should share the same angle because I have calculated from here with the same spaces, angle space, step angle I mean. So that's we already know what's the step angle here by looking back to this one. So we could just use the half size of this angle, something related to this one. Okay, so let's go back to this arc and have that step angle and set it as a detail attribute so that we can reuse it inside this node to rotate or to create an offset with these points. Okay, so let's see what's the step angle for this arc. And if I look at it, we need to know the difference between the point and the next point. And in order to do that, it's not really clear what that is. We have a total angle. So let's see. The total angle is we can use the offset. So pi minus offset pi multiplied by 1 minus offset multiplied by 2. So that should be the total angle. And let's have that as a detail. Set detail attrib. I'm gonna call this T-ang. And we can also calculate the step angle as well from this total angle by dividing the total angle by the number of points. So in this case, the number of points can be estimated from this one here, because at this point this is just a line, and we have wait a minute, no, this doesn't work because we are resampling it right here. So maybe we just need to have total angle, and we can just recalculate the step angle later. Okay, yeah, that should do it. So we have this total angle applied to the detail. Let's check. Like this, close to pi. And let's make sure that it is alive here. And we are going to use that to recalculate the step angle. So let's first get this total angle from the detail. Okay, and then the step angle is a total angle divided by a number of points on the vertical direction, which is corresponds to this one. Okay, and I want to make sure that I want to make the number of vertical lines smaller so that way I can check it by just looking at it. So right now I have 1, 2, 3, 4, 5 points, but the division is equal to 4, so if the actual number of points is equal to 4 plus 1, and in order to get the step angle, you just need to divide by the number of edges instead of points. So 1, 2, 3, 4, so that is equal to the 3 divisions itself. So the actual step angle is total angle divided by the V divisions. Alright, so that should be it, and that's the angle that I want to use to rotate the even number vertical point positions. Now, and I want to make it half size, just in case. And let's make this move in back, just like this. Alright, so next thing I need to do is to pick the even number of these vertical edges, and you can do that by using this HID, horizontal ID. If you divide the HID by 2 and calculate the remains, if it's equal to 0, then that's the even number. If it's equal to 1, that's the odd number. So if it's equal to 0, that's when you want to rotate the point. Okay, so and in order to rotate, I'm going to use the matrix here. And in order to create a rotational matrix, you do need a axis for the rotation for each point. And so in order to do that, you need to, if you want to rotate, what I would like to do here now is to, let's say if I'm looking at the side view, what I want to do is to rotate this curve to this direction by some angle. Okay, and this angle, we have calculated this angle already, so what I just need is the axis. If you look at the in 3D, you just need to have the axis in order to rotate this curve to this direction. Now we don't have that axis vector yet, so we need to calculate that. We could easily do that by first get the normal direction of the curve, or the horizontal direction of the curve, which we could calculate that by using cross product between the point position and the up vector. Is it? No. I mean, this vector itself can be calculated just from the point position, and by calculating the cross product between the up vector with these vector, you can get the axis. Yeah, that should do it. So first I'm going to calculate the horizontal directional vector for each point from a point position, which is, I'm gonna call this H direction, which is a set point X, and for Y make it 0 and use Z and normalize it. And let's check this direction by having applied as a edge direction attribute, just to make sure that I am on the right path. Alright, so it's the flat directional vector toward horizontal direction, yeah, for even numbered vertical curves. So that's good. Now the next things that I want is to calculate the cross product between this vector and the up vector so that I can get the perpendicular vector value, which can be a axis for the rotation. So axis is equal to cross between the h direction and the up vector, and let's normalize this as well. Okay, and let's also show this axis just to make sure that I'm doing right. Okay. Make it red. Vector. Oop. Okay, so these red value, red arrow is the red direction is the axis, which seems fine, which seems correct as a axis for the rotation. All right. So now that I got this axis, it's time to rotate the matrix with an angle that I have calculated right here with an axis. And now we can just rotate each of the point, which is at the even number positions. So you can just do that by multiplying the point position, the current point position, by the matrix. All right, there you go. I think it worked. So it's been shifted the half angle size to upward in this case. Yeah, looks good. And this point position, the shifted point position is actually going to be the point for the Voronoi center. Okay, so let's do this. And do we need anything else? No, I don't think so. Okay, so let's have a Voronoi fracture. Now for the vase shape for the Voronoi fracture might be better with the smooth surface instead of this a bit low res shape. So we can go back to an arc before the resample, which we had 50 points for this profile. So I'm gonna directly create a revolve out of this arc to make a bit more smoother surface with the division set to something higher, like 50. Alright, so let's say this is smooth enough for the base. And I'm gonna use this as a base for the Voronoi fracture. So bring this back to right here, and for the center for the Voronoi, I'm gonna connect this one. Okay, as a result, you don't need an interior surface. I'm going to uncheck this, and as a result, you should see these ridge edges create something really similar to what I see on this image. Okay, let's remove those interior edges by using divide node. I remove shared edges and make it recalculate the primitive normal to see how it looks like. Yeah, looks like a corn, sphere corn, but it is also pretty similar to what we see here as a part. So it looks good. I like it. And by changing those parameters, the number of vertical points and horizontal points, should be able to see it still works with the same rule. Okay, so that looks good. So this is going to be the base for the sea urchin skeleton. Okay. Now this is a bit regularized shape, which is because I'm just recreating this from the really regular sphere shape. So it's the alignment of the cells is pretty clean, but there is a chance that you want to like move those point positions randomly to make it more randomized cell shape. So I'm gonna create an option to do that now by just using a remeshed version of this sphere just as an option. So create the switch node, and what we want to switch is the point position for the Voronoi, so I'm going to connect it right here. And instead of using these regularized point positions, I'm just going to create the point position from the remeshed geometry by using the remesh to this smooth surface right here with some kind of target size parameters. Now there is a bit of problem with this remesh because it thing is that it doesn't remesh the border, the unshared edges. I mean the shared edges. Unshared edges, is it? So the size of these edge becomes smaller compared to the one that it's in the interior, which I don't really like. So I'm gonna try to make those edge lengths similar to what you see on the exteriors, or I mean the interiors. So to do that, first I'm going to create a group for these unshared edges by using group node, name this border, uncheck the base group. Instead, use include by edges and check unshared edges for points. Now you can only select the border points. Now to those border points, I'm going to use the fuse node to merge it together with some distance, similar to what you set right here, target size. So I'm gonna copy this target size and paste it to a snap distance and multiply by some small number like 0.7. There you go. Looks a bit better. There are some like glitches like here, but that shouldn't be a big problem. Okay, so it looks good, and I want to use this as another option for the point positions. Let's see how it goes. So this is the regular point positions. If I switch this to the remesh point positions, it becomes something like this, which is also similar to what you see in centroidal Voronoi tessellations. Something like these. Because remesh itself have this smooth iterations right here, which tries to move the point to have this similar distance in between. So as a result, it will give you the same similar results to centroidal Voronoi tessellations. And by increasing the iterations, you get more kind of a hexagonal like shape. Okay, that looks good. Now I guess it's time to promote those parameters that I have also set. One is for the shape switch, whether you want to use the shape 1 at the regular switch, regular size, or a random size, random shape. So for that, maybe I can just use the toggle to use, say, random shape. Okay. So if the toggle is checked on for this random shape, use the remeshed one. If it's checked off, then use the regular offset shape. Okay, looks good. Now there are some other parameters like the target mesh size for the remesh. So let's also copy that, which is this one. I'm gonna name this random size. Random size. For the regular ones, I'm gonna name this shift. The parameter could be, maybe there are no parameters for the regular ones. Okay. Yeah, I don't think there are any parameters, so only for the random ones. Okay, so we can continue. So now that I have got this base, I'm gonna do with the regular ones. The next thing I'd like to do is to use the create this circular mountain-like shape for each cells. I got a comment. Isn't there an option on the remesh node to ignore the border? I believe there is something. Really? I've been looking my whole life to do that, but I couldn't really figure out how. If you know where that is, that'll be great. Let me know if you know where I could do that on remesh. Couldn't really. There's not much parameters in remesh, so I'm not sure which ones for that. Adaptive? Maybe not. Yeah, let me know if you know exactly where you can do that. Hans Reindl. Thanks for that. Okay, so where was I? Let's create the cells. So until here I have created the base. So I'm gonna make this as a group. Alright, then first thing first, what I would like to do is to set a ID to each of the primitive or each of the cells so that I can use it later at some point. So after normalizing, I'm going to use the primitive wrangle to set an ID. Set an ID from the primitive number. Right. Okay. And okay, so the things that I want to do here is let me try to find out what I was trying to do. Let me see what I was trying to do. Okay, I am first going to connect this to some null node named as base, which is just to organize, and then I'm going to fuse this whole geometry so that if the edge is connecting, all points will be merged. Okay, then let's also show up the points. And what I would like to do in order to create a circular shape an interior of each cells. What I'm going to do is to offset this outline curve inward. Yeah, inward to and smoothen out this inward lines or curve. Okay, I'm gonna rephrase it. What I'm gonna do is to create an offset curve for each cells to the inward direction. Then if you just offset it, then what you get is kind of a hexagonal hard edge shape. But the next thing you want to do is to use some kind of a smooth functions like attribute blur node to smoothen out the interior edges to make it close to circular shape or ellipse shape. Okay, so that's my plan. So in order to do that, I'm going to pick each of the primitive and create some inward offset just by scaling or setting the total number of offsettings, then linearly scaling smaller and smaller for each shape. Since everything is a convex shape, because it is out from the Voronoi, just using the scale is totally fine, I think. If it's concave shape, then that's a big problem, but right now it's not a problem. Okay, so before doing the offset, I don't like the number of points on the edges, so I'm going to use the resample node to recreate the points, check the resample by polygon edges, and make the point number maybe smaller you get, higher resolutions or a smoother result you get. Maybe 0.05 is fine for this shape. Okay, and it's time to create an offset, and you could always use like something like for each primitive. I don't really want to use that. It's the last thing I want to use because it's slow, so I'm going to try to calculate all of those offset just by using primitive wrangle, which should be faster. Yeah, I hope. Okay, so and so first thing I want to do is to get the center of each of the cells on primitive wrangle, which is simple. You can just get at P. That is the centroid of the primitive, and you also want to get the total number of points for each primitive using prim points. Okay, and for each point I would like to move it inward by the total number of layers. So we also need to define how many layers we want inward, like that. Let's say we want to have 10 layers. Okay, so for each layers I'm going to create a for loop. Just like that. And for each layers we want to move each point, so we have another for loop. So this is already not so optimized. Maybe if you want to make it more optimized, you should use maybe a point wrangle instead of primitive wrangle, but using primitive wrangle is a bit easier. So okay, thanks for the comment. Remember the poly reduce node is removing points from the borders. Remesh is, I see. So poly reduce does that. Okay, That's good to know. I'm gonna try that later. Thank you. Okay, where was I? So, get the point number. Vector positions. Get the point positions from the point number. Just like that. And what I would like to get is the actual target point positions, where to move the point for each layers, which is in between the current point position and the center, and based on the I value, which is the number or iterations of the layers. So I itself is a bit hard to use, so I'm gonna refit or remap this value in between 0 to 1 first of all. Okay, so float f is equal to I divided by number minus 1, which will give you a value in between 0 to 1 for this I value, which is the number of layers. Okay, so by having the value in between 0 to 1, it's more easier to use. In this case, we can calculate the target point positions, which is in between the current point position and the center, and by using f, you can lerp or tween the point position from this to this. So if it's 0.5, then you get the point position between this one, the middle point position in between this one. If it's 0, you get the original point position. If it's equal to 1, then you get the center. All right. So, and what I want to do is to create the new points and use this new point for a new offsetted lines. So for each layers, I want to create a polyline. And for each primitive, I would like to create this new target point added to the polyline. Alright. Okay, now I am seeing something here, but the original primitive is a bit noisy, so let's remove the original primitive, which I don't really need anymore. So remove prim 0 prim num. Okay. Now it's a bit hard to see, but I can see that I am having I'm having each of the cells with these offsetted curve, and I can see that there's some openings in between the first point of the edge and end point of the edge. So I want to close this one. In order to do that, we need to add the first target point position, which was added to this primitive, at the end. So let's have a variable first tpt, and if the n is equal to 0, then first tpt is equal to target point, and that's the point that I would like to add to a primitive at the end, so that you can close the polyline shape. Oops. Yeah, just like this. Okay, looks good. It's a bit hard to see. Okay. It's really hard to see. Okay, so next thing I like to do is to smoothen out these inner shape or inner polygon which is a bit too hard edges. Let's reduce the number of cells so that we can easily see what's happening here. Okay, something like that. Yeah, still hard to see. Okay, so right now you have too hard edge in interior, but what I would like to have is a bit more circular shape inward. It's okay to have a hard edge on the outside of the close to the edge of the cells, but not on the center. So we need to have some kind of a weight value applied to each of the layers and use that weight to control the amount of smoothness or blurring. In this case, I'm going to use a attribute blur in order to smoothen out. If you don't have any weight value, which is this one, everything will be smoothened out like this, which is a bit problematic. As you can see, the edge is no longer connecting to each other. The cell edge is not connecting to each other, which is still interesting, but not that I want. So in order to fix the boundary, this boundary of the cells fixed to the hard edge and gradually smoothen out toward to the circular shape, we need to apply some weight value based on the layer number, which is this F value, I think. We need to set some attribute somewhere around here. Right after I created the new point, I'm going to say set point attrib weight to this target point with F. Just using F is fine, I think. Okay, going back to the attribute blur, I can now use this weight attribute, and now starting from 0, so that 0 means you don't have any smoothness, so it is fixed to the boundary, and gradually it's changing to this circular shape, just like this. Looks good. And you can control the whole amount of blur by controlling this blurring iterations. I'm gonna set this to 50, but it's your choice here. And let's also try increasing the total number of layers, like 20. This is just to control the resolutions. Yeah, so any number should be fine. I'm gonna fix this to 15 to have enough number of edges to control. I mean, more layers you have, more detail, like mountain shape you can create, so it's up to you. Maybe this could also be parameterized, but maybe not, because it's not really directly visible to the visual, so I'm just gonna keep it as it is. Okay, so looks good so far. One thing I don't like is that you see that there's some curve here. Because I use the smooth, it's no longer on top of the surface, on top of the sphere surface anymore. So let's make this back to on top of the sphere by going back to a sphere geometry, which we could go back to this one. Yeah, this is the smoothest one. Maybe I can make this smooth and use this as a guide. Use this as a geometry to snap on top of. I'm gonna use the object merge to get the smooth shape, and use the ray node to snap the point to this smooth surface using the point to minimal distance. Yeah, that should bring those point on top of the sphere back again. Okay, like that. And let's connect to the null. Now, so far so good. The next thing I'd like to do is to create a surface out of these curves. And you can do that by using a skin node. Now skin node itself is trying to connect all the curves together so you have some buggy shape like this. So you need to use some kind of options shown here, either group of n primitives or skip n every nth primitive. So in order to use this, you need to know how many layers you have which you want to connect together. Okay. In this case, we are setting this layer numbers right here, which is currently 15. So I can copy this value, go back to the skin, and this could be a group of n primitives, I think, and paste the value here. And now you should be able to have a clean shape for each cells. The skin has been created for each cells using 15 curves. Okay, that looks good. Now the base shape for the mountain is created. Next thing you want to do is to create a mountain-like shape by moving those points to the normal direction by some kind of a shape controller. Yeah. So let's do that. I'm going to do that again by using point wrangle. Let's name this set height. Set height. Okay, and so we do need to have some informations for each point in order to determine which point position have with what kind of height. Now we already have some informations on each point, which is this weight value, which goes from 0 to 1 based on the layer number. So we could directly use this to control the height value as well. Yeah, that's convenient. So let's calculate, let's create the height value, and we could use the weight value together with the ramp parameter so that we can control the shape manually. And we also want to control the maximum height value as well, so we could have that as a parameter. So we have two parameters, one is the shape, one is the total height. So let's say the total height is 0.2, oops, 0.2, and right now the shape is linearly growing up. We could try that. And in order to move the point, we need to have a normal direction for each point, which I'm not sure if I have it right now. Maybe, yeah, maybe it's being automatically calculated, but there's a bit of problem right here. Maybe this wouldn't give a better result. So let's see if I can recalculate the normal direction. Maybe not. Maybe this point would have some problems, but since this is close to the edge anyway, which will give you a value 0 as a height, so shouldn't be a problem. Okay, now I'm going back, and what I would like to do is to move the point with the normal direction multiplied by height. Okay, well, there's some problem here. Okay, let's see if I can fix that. That is happening where we are having a small shape. Yeah, something like these. Something really small. Which one we want to ignore it. Okay, it seems like we are having really small cells right here, which is creating some problem, obviously. So let's see what we can do with this. One thing I could think of. Dun, 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 dun. What if I don't recalculate the normal direction? Which, no, not really. Okay, the bottom part is okay. The top part have some problems, so maybe I can go back to this shift. And let's say if I rotate this in negative direction. Let's see what happens. Now the bottom part has some problem. Okay, understandable. Understandable. So we can go back here, here. Maybe at this point we could calculate the area, and if the area is too small, then we can just remove it. Maybe that's one thing you could do. Measure the area. Check. So some part has really small value, like less than 0.001. So for those that are really small in terms of the area, we could just remove it, maybe using delete node. Area less than 0.01. Now you should be able to trim out those too small shape on the edge, which might not be an ideal solutions, but let's try with this one for now. Okay, now it looks good. Now it looks good. Now right now the mountain is a bit too linear, as you can see, which is because I'm using the linear shape here. Let's try to fix that, or let's try to control this. First of all, I'm going to make it B-spline so that you can have more curvy shape. And let's go back to the image, what kind of mountain-like shape I would like to get. Okay, so this is so you have some ridge here. You have one kind of a hill on the outside and another kind of a hills on the inside, and you have small holes on the center. So let's see if I follow that, should look like something. Okay, so it's starting to look like that. Make a hole. Control the height a little bit. Now looks pretty close to what I see now. Oh. Yeah. It's not like exactly the same, but close enough. Not really good at those manual tweaking, obviously. But yeah, I think I like the result. Okay, so let's say I'm good with this. Now it start to become pretty evil already. Make it lower. All right. Like it. So, as a base shape for these cells, I think it's good enough. So, let's have this named as cell. Okay, and let's see what it looks like with the Voronoi shape. I mean the random shape. With the random size a bit bigger, still looks fine. More like a bomb. C-bomb. Alright, like it. Okay, so the next thing I like to create is these bubbles surrounding these cells. And you can see some kind of a gradient size changes from the edge to the center. At some point it just disappears. So I'm going to reuse the weight value and try to create those scale information. Okay, so at this point what I can say is this is the base shape. Okay, so I'm going to name this cell. Okay, so in order to create the sphere shape, first thing you need to have is the point position for those bubbles, right? Obviously, which can be created from this shape, I guess, because we want to put the spheres on top of this surface. Okay, and if we look at the surface, the point wrangle, point attribute, we still have this weight value, so we could use this weight value to control where those points should be placed. And in order to place the point, what I'm going to use is this scatter node. And if you just use the scatter node as it is, it will just uniformly placed on top of anywhere on the surface. So in order to place those points specifically around the border, we need to use some kind of a density value using density attribute. Okay, together with maybe force total count. So to do that, we need to specify this density value to this surface. So let's do that. Density for bubble. Okay, so you could just use the weight value and try to remap it to something reusable for the density. Now you don't want to place the points somewhere close to the mountain, so maybe you can trim out some of the values out of the weight and make it 0 if it's above maybe 0.2 or 0.3 as a weight. So F density is equal to F weight, and we can use the fit function, and let's say if we are remapping the value between 0 to some maximum value that we want to use as a point position or the surface position to place the point. Then if it's close to the border, you want to have more points, I guess, or yeah, more points on the border and less points on the middle of the surface. So 1.0 first and 0.0 second. Okay, so I have just given the density value as an attribute to the surface point, like that. And let's see what happened. And I realize I didn't set the maximum, so let's set this to 0.2 for now. Connected this to scatter, and I can see that the scatter point is using the density value somehow to place those points. Maybe I can increase the number of points to 5,000. Okay, it's more clear. And let's try to place some sphere without thinking about the scale for now. Change this to polygon. Maybe low res polygon is fine. Copy 2 points. Maybe obviously the sphere is too big, so make this really small. Maybe that was too small. Something like that. Okay. And merge it with the original cells and see how it looks like. It's close to what we want to see here. Okay, now we could try to tweak those maximum parameter that I've set. More value you have, closer you get, you have these points to the mountain. So I think it's okay to reduce it to something 0.2 or 0.3. Now, one thing it's missing is the size, the scale value based on the position of the edge, obviously. So let's fix that as well. So if it's close to the border, you have smaller size, and if it's closer to the edge, the middle, you get bigger size. So, and we can determine that by looking at the density value, I think. If you look at the density, if it's equal to 1, then it's closer to the border. If it's equal to 0, it's closer to the edge. And if it's closer to the edge, maybe we can make the size of the ball bigger. If it's closer to the border, we can make the size of the ball smaller. That's what I could do, and that's what you want to do right after you created the scatter point. So I'm gonna set the p scale to each point based on the density. So scale is equal to, first of all, get the density value, and we can use the fit function like fit 0, 1, because the density is in between 0 to 1. And if it's closer to the border, we can use smaller value like 0.005. If it's closer to the center, a bit bigger, and make it as a p scale. Wait a minute, it might be other way around. Let me try. Okay, where did it go? Okay, so I should make this 1. No, I think it was the other way around. This should be bigger. This should be smaller. Okay, obviously the size is not that big enough, so let's make it bigger. So 0.2. That's too big. 0.01. No, 0.05. Maybe. And maybe we can increase this max value to 0.3. 0.25, and increase the sphere's resolutions a little bit to make it look like a sphere. And for the smaller value, maybe 0.01 is fine. Yeah. Okay, getting closer, getting close to what I see here. Yeah. And maybe I can increase the number of points a little bit more to 10,000. Okay, getting better. Getting more evil. Okay, I think I like it. So far I have created the base shape for the sea urchin and following these shape. Now the final thing I'm left out with is these strips, which is dividing these cells. Okay, which looks like it's growing to a horizontal direction. Okay, so that's what I would like to create. And last, let me reduce the height a little bit. Okay. Now, it might also be a good idea to colorize these shape a little bit so that it will be more three-dimensionally obvious what's going on. I'm going to create another point wrangle. Use the color node. And probably I could just use this density as a color value. So I'm just gonna copy the density for this one. And let's name this bubble. Like that. For the cell, let's see what I could use as a color value. Maybe this height. Yeah, maybe the height. Height could be a value, or the weight. Either thing, maybe weight is better. So point wrangle color. Color is getting from the weight. Okay, now I can use the color node to use this color attribute to create the color based on this attribute. You can just try to use some random. Nice. Okay, looks good, looks nice, looks evil enough. Okay, maybe I don't really like the shape after all. Okay. Now, before going to the strip, I'm going to promote some of the parameters that I created. Okay, so let's check what kind of parameters that I created. I haven't used this ID yet. Offset. So 15, what was this for? Offset cell, oh yeah, number of cells, a number of layers. Yeah, this could be parameters, which I said I don't need it as a parameter, but maybe it's better we have it. Okay, so cell layers, cell layer num, 0 to 20, 1 to 20. Okay, and attribute blur. This could also be a parameter, a cell smoothness. All right. What else? Scan set height. Yeah, this is obviously a parameter you need to use, which is the cell height, as well as this cell shape. Okay. What else? Color. Yeah, the color as well is a parameter you could control by yourself. Color. And for the bubble, we have another set of parameters, such as this one. First of all, this is I could say bubble region from 0 to 1. Scatter node, how many points you want to have as a bubble number, and the p scale, the maximum scale and the minimum scale, which could be parameterized as well, I guess. Minimum scale. This is the bubble min scale. Bubble min scale. Bubble min scale. Bubble max scale. Bubble max scale. Right. And both of them could be that the maximum could be 0.1. Alright. That's pretty much it, I guess, for the bubble and the cells. Okay, so it's now time to create a strip. Alright. Let me just test out those parameters if it's creating what I'm assuming to create. Yep. Pretty evil. Random shave. Yeah. Cell layers, maybe it's not really visible. Cell smoothness, this could be visible. If you make it less smooth, you have heart-shaped cell, which is more like a sci-fi object. Yeah. Okay, wait a minute. It's opening. Now that's a problem. I need to fix this one. Where did it happen? Is it happening everything? No, just some of the cells is having this opening. Why is that? Let's go back. Let's go back and see why. So at this point, okay, so maybe there are some This might be doing something wrong here. Before projecting with the minimum distance, maybe I could fuse it. Probably. No, nope. Not a good idea. That is because it's removing the center point here. If I set the uncheck this one, what happens? Still have some problem here. Funny. Wonder if it's already being having some problem right here. Let me show up the point number. Oh, that's too noisy. Okay, what if I don't use the ray node without the fuse? See what happens. Okay, this is doing good, but I do see some openings. I still see some openings here. Why is that? Why is that? Let's go back to this one. Maybe there are some problem with this part right here, which is not closing, obviously. But if it's not closed, then by using this should give you some problems, so it should be okay. Maybe a problem with the skin node might be possible. So after the skin, maybe I can fuse it. Then set the height. Okay, that should fix it. Okay, so I could still use the ray node. Alright. Where was I? So, yeah, to create the strip. In order to create the strip, I'm going back to where I have created the base, and things that I want to do is to create a in-between, like some kind of a space with a bunch in between a bunch of cells, like somewhere around here, or maybe somewhere around here, and you don't know how much strip or a split you want to have. Maybe it could be 3, it could be 4 or 5 or something like that. So let's also make it parameterized as well. So looking from the top view, what I'm gonna do is the current shape is like this, and I'm gonna split the shape into some numbers like 4, and trim each of the cell set and move it outward. Like this. And by doing that, you have a space in between the cells, and that's where you're going to create a strip shape. That's my plan, which is this one. Okay, so first thing first, I need to create a cluster, number of clusters to move outward. Okay, without changing the size, I'm just moving to a single direction for each cluster, going to to the outward direction, maybe on XZ plane. So the first thing I need to do is to create a cluster, and to do that, maybe I can categorize or create the cluster based on the angle for each center of the Voronoi cells. Okay, so I can calculate the angle based on the XZ plane for each cells, and based on this angle I can divide it into like 5 sections or 3 sections and so on to make it as a clusters. That's my plan. Okay, so shall we do that? So first thing first, what I need to do, let me think. What was that I need to do? Okay, so first I am going to create some a cluster ID to each of the primitive. Okay, from this base. So primitive wrangle clustering. Okay, so first let's calculate the angle for each center of the Voronoi cells, which you can get the center by getting the at P, and you can calculate the angle on XZ plane by using A tan to using the center Z and center X, which will give you a value in between minus pi to pi, in total 2 pi. It's in order to create the clusters, it might not be a good idea to have a negative values, so I'm going to make it positive by adding pi, so that it will be in between 0 to 2 pi. Right. Now that I have this angle value, it's time to define how many clusters you want. Okay, let's say 5. Maybe that's too much. Well, I don't know. Okay, so if you want to have 5 clusters, and first thing you want to do is to divide this angle by 5 or by 5. So if you divide 360 degrees by 5, you get 72 for 72 degrees. Okay, so from 0 to 72, if the angle is in between 0 to 72, then the cells is in the first category or first cluster. If the cell's angle is in between 72 to 144, then the cells is in the second cluster, and so on. So that's how I'm going to determine that in which cluster the cells is in. Okay, so first I am going to calculate the division angle, which is pi multiplied by 2, which is 360 degrees divided by this cluster number. So you get 72 degrees in this case, because the cluster number is 5. Okay, now next thing I'm going to do is to use this step angle or cluster angle with the angle of each cluster to get the division ID or cluster ID by dividing angle by the division angle and get the floor value. You get a value in between 0 to 4, which will be directly the cluster number. Okay, let's check this out. So I have created the cluster attribute to primitive, and let's try to visualize it, see if we got that right. I think we gotta say this is for the primitive. And So these primitives are equal to 0, these are equal to 1, these are equal to 2, 3, 4, so seems correct. In total we have 5 clusters based on the angle. And if we change the number of clusters like 3, we have in total 3 clusters, 0, 1, and 2. So in between the different clusters, that's where you want to have the ridge line or split lines or strip lines. Space, I mean. So in this case, somewhere around here, I guess. Like that. Okay, so far, so that's good. And let's just try to move using those information in the same wrangle node. So we can do that by having this cluster ID as well as by determining the actual direction where we want to move to based on this cluster ID. So that should be a multiplication of 72 degrees in this case, if it's 5. But if you just use 0 or 72, then it will just use the edge angle, so maybe using the half value of 72. So that's 36. Might be good as a directional angle. Starting from 36 and then multiply, adding the multiple number of 72 might be a good idea. I don't know if that makes sense. I'm just gonna try it. So moving angle is starting from the division angle multiplied by 0.5, which is 36 degree, plus division angle multiplied by division or cluster ID. So we can write this more simpler. Something like that. And this is the actual moving angle where the set of the clusters we want to move to. So maybe for cluster 2, this is the direction we want to move as a whole set. And this should be the angle for that, hopefully. Let's see. So in order to determine that, we need to convert this angle to the vector value, which we could do that by using, again, a trigonometry. Vector moving direction is set cosine move angle 0 for the y and sine moving angle for z. Multiply by how much you want to move actually as amount. Okay, so we want to, let's say I want to move like 0.2 to this direction. And in order to move the point, since we are at the primitive wrangle, we need to access each of the point of this primitive. So get the primitive points, use the for loop, and move this point to this moving direction, and then update the point attribute P with updated position. Okay, I think it's going other way. to the negative direction, seems like. Yeah, seems like the angle is correct, but it's going to the negative direction, so I am going to make this moving direction negative, so going outward. Alright, looks good. Now that I have splitted the bunch of cells as a cluster, and if I change this value, you can define how many clusters you want to have, like that. Maybe some, if the number is too big, you have some kind of a weird cluster, so maybe you want to make it smaller. 4 or 5 looks good. Let's see if this could also work with the random pattern. Let's make this random size smaller, and seems like it still works. Yeah, even for the random. Now the ridge edge, the strip line is a bit more randomish, of course, but still works. Still works. Okay, that's good. Because I'm using the really simple rule here. Okay, so that's good to know. Going back to the regular shape, let's go with the 5 clusters. Now, next thing I would like to do is to create a connection between those edges, the splitted edges. Looks simple, but it's not that simple, I think. You need to have some information how you can connect these together. And right now I don't have any like informations in order to connect these two, so I need to create that as an attribute. Okay, so in order to do that, first I need to know if I probably need to set some ID value before splitting. Like at this point, I need to know that before splitting, this point shares the same ID. And even if it's been splitted, so that we can know that this point and this point used to be the same position. Okay, so before moving the clusters, I want to recode or create some attributes to determine that, to specify that these points used to be at the same positions. Okay, so I'm gonna do that by using point wrangle. And in order to use the same value for a same positions, maybe it might be a good idea to first of all fuse it and use this fused geometry as the information, because by using fuse you can merge all those points which is at the same position, so we can use this fused point number as an ID for each point. Okay, so I'm gonna connect this fused geometry to the second input and the base to this first input of this point wrangle. Transfer ID. And I'm gonna create the ID value for each point from retrieving from the merged fused geometry. ID is equal to near point 1p. That's all I want to do. So by doing this, you are using the current point positions in order to look for the nearest point from the fused geometry, and there's only one point on the corner, on the intersected corner, so you only get one unique result as a ID value, and that value will be transferred to each of the point at the corner right here. We have 3 corners, so we have 3 points right here right now, and each 3 points will share the same ID, which comes from the fuse node. that is the same even if it's been splitted. So this point and this point should share the same ID. Let's check that. Let's check that out. For point. Okay, so this is 102, is it? It's a bit hard to see. So this is 19. This is 19 on the corner. So, and this is 19 on the corner. So yeah, sharing the same ID. Okay, maybe there are a bit too much in between points. So let's see if I can remove those first of all, using maybe facet as much as possible. So using facet node, I can use a remove inline points. Try to remove if it's too straight, but this will give you an opening, so forget it. So this is good. Okay, now that I have this information sharing the same ID, it's time to use this to connect to each other. The strategy or the method that I'm gonna use is to first of all create the line connecting each edges, then create some lofted shape or skin shape to connect these lines together to create a strip. Sounds simple. Now, in order to create a lines, we need to look for one of the edges, either this edge or this edge. If you try to connect the lines from both edges, then you get the duplicated lines, which is not ideal. So let's just pick one of the edge on one of the clusters, and from one of the clusters create the line. In that case, we could also like keep the order of the lines, keep the direction of the lines together the same. So by creating the loft geometry, we don't have like flipping in the last. So in order to do that, in order to determine from which edge we want to start creating the line, we could check the cluster ID again for each cells, and if maybe the line can start from where it touches the cluster bigger than the next one or smaller than the next one. Either way is fine. Okay, so that's my plan. Okay, so let's do this. And in order to create the lines, I'm going to use the point wrangle. Okay. Now, and so these are the points that I want to look at. And at this point, we don't really know which point is going to be picked from this point wrangle. But let's say if we can create the conditions inside the point wrangle later. So first of all, I'm going to find out all the corresponding points sharing the same ID to the self by using find attribute null for a point class using ID sharing the same ID, which will also give you the self point number, so we need to remove that one for sure. So for each point, get the point number, and the first condition we need to give is if the point is not equal to the current point number. obviously. That's the first conditions you need. Okay. All right. Now let's get the second condition is that if the point, let me check the primitive wrangle of primitive attribute, and you see that for each primitive you have this cluster attributes. So this one probably have 2, this one probably have 1. So if the point shares the same primitive, same primitive cluster attributes, somewhere around here, even though you have a similar IDs, same IDs find at the positions, but if the other point shares the same cluster ID, then that's not what you want to connect with as a line. You want to ignore that. So that's another conditions you can create. So in order to do that, we need to retrieve the cluster value from the point, which you can do that by first of all get the primitive number from the current point. So prim, and in order to check with the other point, we need to have the second primitive number. So I'm gonna say the prim1 is the self primitive number, and primitive 2 is the target primitive number. Okay, so point prim0 ptnum first one, because it should not be connected to the other primitive. Okay, point prim0 pt. Okay, and cluster 1 is prim0 prim1 cluster prim1 cluster 2 prim0 cluster prim2. Okay. So we could use these clusters, 2 different clusters, to check if we can connect the lines or create the lines or not. Okay. So thing is there's always a rule that the clusters next to each other is equal to value plus 1. So 1 plus 1 is equal to 2. 2 plus 1, 3, 3 plus 1, 4, and this is a irregular place where it flips. The 4 is the last number, so if you add it by 1, it goes back to 0. Okay, that's we need to consider about. So by thinking about it, we could create the condition something like this: cluster 1 plus 1, and create the modulus. Calculate the remains by the number of clusters, in this case 5, and we have that information previously right here. We could copy this parameter, bring this as a value, num cluster question, calculate the remains with the number of clusters, and so this will give you a value in between 0 to 4 always. And if it's equal to cluster 2, then that's when you want to create the line. Yeah, I think so. Oops, what did I do? Okay, so this should be the conditions to use, and let's see if it works. Add prim0 polyline polyline between the current point number and the PT. And nope, didn't create a line, did it? The number of primitive didn't increase, so maybe it failed. Okay, let's see why. So I have number of clusters. Maybe the condition is not working. Maybe this part is not getting anything. Probably. First of all, I want to make sure if this condition works. So I'm going to apply this cluster or just random value, see if the condition is working for some of the point. Yes, it is. Okay, next I will check if the cluster is being retrieved correctly. Yes, for cluster 1, yes. For cluster 2, yes. Okay, so seems correct. Seems like I have got the correct information until here. So maybe this right here is something that has some problem. Okay, this is the problem. Spell mistake, polyline. Okay, so I don't really like this one here. The reason why I have a split like this is because maybe it's calculate the angle from this x-axis or this axis right here, so maybe couldn't determine whether this cluster or cell is it at the right cluster or the left cluster. Okay, so maybe we need to have some kind of an angle offset in order to make a more accurate precision accurate clustering. So the simplest way I could do that in order to create a kind of an angle offset, just to use the transform node before creating the cluster IDs. I can just rotate it to y axis, and that should give you a better result. Maybe this could also be parameterized for final tweak. Okay, looks good. So now that I got these lines, it's time to connect these together to create the strip. But wait, what do we want to do with this strip? What I want to do here is to, instead of creating the hole like this, I would like to create the bubble like I did for these cells. So somehow I want to create a base point for the bubble from these line information. And what I could think of is to create a zigzag contour, just like the vertical lines, and maybe smoothed out on the center, then go back to the hot edge, just like we did for these cells. So I want to do similar things for these lines. Okay, so to do that, first of all, I know that the number of lines for each strip is different, so we cannot directly use skin together with this group n of primitives because it's fixed to one value. So instead, we need, probably for this one, we need to use some kind of a for loop, unfortunately. Or maybe there are maybe some optimized way to do this, but couldn't figure it out. Well, anyway, let's call this lines, and I think it's a good idea to split the cells base and the lines so that we can work different separately. So for the lines, I'm going to set the group, set prim group, line, prim, line, and split it. Okay, so for the cells, this one, we can connect back to right here, which should do the job to create the cell shape. Now what we need to do is to fill these gap with a new geometry, the strip geometry. Okay, so just this one. Okay, so first of all, I think it's a good idea to again clusterize these set of lines using the same attribute for same strip, so that we can use something like for loop for each loop. So going back to the lines, I'm going to create an attribute to each primitive. Set prim attrib. Set prim attrib. Let's name it line ID with using the cluster ID. Okay, cluster 1. So by using this line ID, I can now pick each of the line set using for each named primitive. Using line ID instead of the name. There you go. You can get a bunch of lines as a one strip. Now it's time to create a strip. If you just want to create the surface, I think you can just use like something like skin. Now this has some problem because the order of the line is not based on the height, so let's reorder it first of all using sort the primitive based on Y. Now that will fix the sort problem, but what I want to have is a these zigzag lines and use that line as a base point position for the bubbles inside. So instead of having the horizontal lines, I'm going to create this vertical zigzag lines somehow from these horizontal lines. Going back to the sort, what I could do is first of all doing resample, so to determine how many points or how many layers I want by setting the maximum segments. If it's equal to 10, you will have 10 layers. Maybe that's too much. Let's set to 7. Okay. Now for each point, I just want to connect it like this. For the first point, I want to connect it like that. Second point, connect it like that to create the zigzag lines and so on. Pretty simple. Yeah. And to do that, I still need to set some informations to each of the point to create a line. Yeah. And what kind of information do I need to set? Let's think. First of all, a integer ID to each of the point based on the point ID, point number for each primitive. Okay, so I could do that using primitive wrangle. I'll call it CID get the point list from the primitive for each point. Set an attribute point called CID to each point, and I can just use this I. So the I should be the value starting from 0 to, in total, 6, because we have 7 points for each primitive. So starting from 0, 0, 1, 2, 3, 4, 5, 6, and so on for each primitive. Which in result you should each of the line shares the same ID for a same position. Okay, let's check. You can check that by using an add node to connect those points which shares the same ID. Attribute CID. Right, like that. Okay, that looks good, and now I don't need the horizontal geometry anymore. Maybe before creating the vertical line, I can just remove the primitive and just keep the points. Okay, looks good. Right, so if you make this, and if you combine this with the cell shape, looks close to what I want to have as a result, but somehow it is being offsetted. Not really sure why. Okay, that is because I am using ray node here. Maybe I shouldn't use ray node after all. Yeah, I should just remove this ray node. It's not doing good. Okay, so looks good. Now, next thing I would like to do is to make the inner layers smoother, because every edge, every zigzag line is a bit too hard edge right now. But when it comes closer to the center, I want to make it smoother, just like I did for this cells. Okay, so to do that, we need another this attribute blur with the weight. So to do that, we need to set the weight to make it smoothed out. Okay, so let's see where we could do that. And thing is that we don't want to smoothen out on these edges as well, same as the boundary on these edges. So we need to think about that as well. Okay, anyway, we could do that. Where we can do that? Let me think. Maybe right after I calculated the CID, I can create the point wrangle. Name this weight. And for each point, first of all, let's normalize the CID in between 0 to 1 so that it'll be easier to use. So f is equal to CID divided by the total number of points. In this case, this. So I'm gonna copy this parameter. Paste it right here. Number minus 1.0. This will give you a volume between 0 to 1 from left to right. So if it's 0.5, then that's in the middle. Okay, and that's where you want to have a maximum smoothness. And if it's equal to 0, if it's equal to 1, then you don't want to have any smoothness. So for those cases, you can use sine function with multiplication of pi as an angle to this f. So angle is pi multiplied by f, which will give you a value in between 0 to pi, and then you can calculate the sine function, which will give you a value in between 0 to 1, like a mountain shape, like a mountain wavy shape. Okay, and that should be the value you want to use as a weight. So weight is equal to W, and let's see if we can use that. So before using the attribute blur, right now the point scattering is a bit too random, so I'm gonna use the resample node to make it a bit cleaner. Okay, probably using the resample by polygon edge with smaller value, like that. Okay, looks good. And attribute blur. Uncheck border points and set the weight. Okay, now there seems to be some problem here. Let's see what happens if I increase. Oh, okay, a lot of problem here. Let's see why. First thing I could imagine is because first of all, I want to make sure that these lines are not on the same. I mean, no duplicated lines are exist. I can check that by using convert line. So the number of primitives didn't change, so no duplicates. So, and this should be okay. Yeah. I'm not checking this one. CID should all be okay. The weight shouldn't be a problem. I'm not sure if this is okay. Okay, let's check the weight value. Weight. So yeah, it's obviously wrong. Where the point is at the start point, it should be 0, but it's saying it's minus 0.5, 0. Okay. So obviously that is wrong. Why is that? Number of 0.7, and let's check CID. CID is in between, should be in between 0 to, wait a minute, 7. Huh. Okay. So this is where I did wrong. I didn't really need to make it negative by 1. I can just use the number as it is. Okay, this should give you a correct result. It's close to 0, so that's fine. Okay, going back to the attribute blur. Okay, more or less what I would like to see. So you can see that only the inner edges are being smoothened out. This doesn't really need to be really high, I guess. Maybe equal to 10 is good enough. Okay, but as you can see, there are a little bit of problem on the top side because these point also has been smoothed out and offsetted a little bit, because of the smoothness. Without smooth, it didn't move. Okay, so I guess I want to fix those endpoint, meaning make the weight equal to 0 for those endpoint. So we need to determine where that is on this wrangle. And to do that, let's see, what's the best way to do this? I think it's easier to do it right here because it's already being connected as a primitive, so it's easy to get the start point and the end point from this primitive. So let's do that. What I'm gonna do is to use the primitive wrangle. Get the list of points. And just get the first point and this end point. And for those points, set the weight to 0. And that's all you need to do, hopefully. Okay, let's check. Now the endpoint doesn't move anymore. Oh yeah, that's good. Okay. Now that I have these lines, or maybe before making it smooth, I can just create the smoothed surface by creating the skin. Yeah. Although there are too many lines right here, which I don't really like, so maybe I want to fix that as well. Where can I do that? Where can I do that? Maybe at this point I can use the facet node. Remove inline point. Yeah, this will clean up the point. If it's too straight, you can just remove those points. But the skin shape becomes noisy, which I don't like it. Okay, the facet node can be done before moving the points. Before... And where did I do that? Forget it. Forget it. Just gonna go with this. And for these, I think there is some... Maybe I can just use fuse node. Better. Yeah. Oh well, if I make this shaded smooth, if it's not obvious, that's good. Maybe not that obvious. Yeah, smooth enough. So I think I'll say it's okay. Which is really not, but yeah. Okay. So what I wanted to do is to create the point position for these bubbles from these edges. So that's what I want to do in the last. To do that, I have already resampled it, so maybe these points could be the candidate for the bubbles. Now since I have used the attribute blur, it should be offsetted from the original surface. So first thing I want to do is to make this back to on top of this skin surface, so that doesn't go like buried inside the skin. using the point, minimum distance. Yeah. Okay. Now that I have this guide lines, it's time to create a bubbles using another copy 2 points. Now I want to also export the skin shape as well, so I can either bring this or recreate it outside. Well, I'll just bring this. Gonna create the group node to this skin. Let's name this strip. Merge it with the curve and split it outside the loop. Get the strip, and for the curves I want to use it as a base point to place the bubble, which is this one. Now for this one as well, we need to set the P scale because right now it's too big, obviously. So I think we could reuse some of the things that I set here. Alright, so I'm gonna copy this one, bring it back to this one, and we don't have this density, but instead we have a weight value. So replace this with weight. There you go. You have some kind of a value, which looks like the edge shape is a bit too big. Maybe there's too much points by resampling. Well, I can't really define if it's good or bad. Let's just merge it together to see. But before doing that, I'm going to organize this. So this is a strip. Okay. And this is a strip bubble. And let's also set some colors based on the weight for this bubble. Okay, as well as this strip. I don't know what will be the best way to describe this color for this strip. Maybe I can just create a single color for this one. 0. Okay. Now that I have 4 informations or 4 geometries, it's time to connect those together, see what happens. If I color it, yeah. Now the size, after all, it's not that bad on the edge, maybe a bit too big. So it's your choice. I mean, I can go back here and maybe for the maximum, I can say maximum multiplied by 0.5. Well, maybe keep it as it is might be good as a contrast. It's not really close to what you see on the real image, but I guess I like this. So it's up to you how you change these value. Okay, looks good. Maybe I don't like those points on the edge. Maybe I want to fix that. Where is that coming from? Oh yeah, that's because I have set the weight equal to 0 for these one. So in order to fix that, I'm going to create additional attribute. Let's call this hval. Just copying the same weight value, but just gonna ignore this one for hval. So, and instead of weight, I'm gonna use hval. As a result, oops, still not doing thing. Why is that? I thought this will fix it. Let me check the value. hval. So 0, 1, 0. So looks correct. P scale. Okay, so this should be where I should use the hval. Okay, good. All right. Okay, so that's good. Maybe this is too vivid. Let me change the color to something more. Why I cannot change here? Okay, I should use this one. Magma. Sand. Twilight. Oh yeah. All right. Okay, like it. So I think all over. Everything has been done to create the geometry. It's time to organize this a little bit and finish this. Okay, so first of all, let's bring some parameters which I have set for a strip. So what will be the parameters? Transfer ID, nope. Clustering, yeah. So first of all, the number of clusters. I guess I should say cluster num. Okay. Move. Cluster separation, I guess, or strip. Clusters. Strip size. Okay. 0 to 1. 0 to 0.5 should be good enough. Lines, no parameters. Split, nope. Resample, this could be a parameter. Yeah. This is a strip horizontal number or division. Maybe 1 to 20. This one is okay, this one is okay. That node. This resampling is also important, I think. This is to determine the vertical split based on the length. So strip vertical split length from 0 to maybe 0.5. Okay, what else? What else? P-scale. Yeah, if you want to change the P-scale, but I'll just stick with the original one. That's pretty much it, I think. Yep. Everything is set. And I am ready to control the shape with anything I want. First of all, color. Oh, yep. Alright. So if I make this random shape, it should still work. One thing I forgot to have as a parameter is the offset angle for a clustering, which is done with this transform node. Float cluster offset angle 0 to shouldn't be that big, 45. Okay, where did it go? Copy it. Okay, so everything is pretty much done. First of all, offset is size of the hole on the top and the bottom. If you make it 0, it will become close to sphere, which still give you some weird shape. And the vertical divisions is for the regular shape, how much you want to divide on vertically. Horizontal divisions is how much you want to divide horizontally. Right. Okay, and if you want to make a random shape, I'm using Remesh node to make it close to centroidal Voronoi shape, tessellations like this. And you can change the size of the cells. You still have this strip. You can change how many layers you want to have for the cell. More layers you have, detail cross sections you can create. This is smoothness. More smoothness you have, more smoothness for this shape. Less, get harder shape. Cell height, obviously. Okay. This is also good. Control the height. Control the shape of the cells. Bubble region. Now this is to control the bubbles. If you make it higher, the bubble get close to those mountains, which looks like a L shape. 0.2 is good. 0.25. And the bubble number. Straightforward. That's too big. And the bubble minimum scale, bubble maximum scale. Straightforward. Right. Cluster offset angle. This is to define the cut, the angle calculation basis. Yeah, it's just to tweet, just to coordinate. Cluster number, how many clusters you want to have, which means the number of strips. To oops. Okay, I think it's gonna give you a error for value more than 3. I mean less than 1, so I'm gonna limit the cluster value so that it will be should be more than 2. Should always be more than 2. Which makes sense, I guess. Okay. What else? Strip size. You can create the size of the strip really big, which becomes something else as a shape. Huh. Something. Maybe not a sea urchin anymore, but something else. Right? Strip horizontal divisions, that's the resolutions of these strip in terms of the bubble. If you have multiple numbers, you get this. Maybe this is a bit too artificial. And this is for the vertical split. Yeah. Okay. And that's pretty much it. And finally the color. Yep. Every color looks good. Yeah, I like it. Really looks like a sea creature. Deep sea creature. And maybe since the whole shape is pretty much close to sphere, maybe I could use another like transformations node to make it more ellipsoidal shape. Somewhere. Where is the best place to do that? Probably right after I have created the Voronoi fracture. Somewhere around here. Maybe something this one. Let's see if I add additional transform node. And scale it only on X and Z direction, see if it still works. Just like that. To create the ellipsoid shape. Because we do see something like that as a sea urchin shape. Like these. Or sometimes it looks more like a egg shape or more of a... What kind of shape is this? Flat on the bottom, round on the top. Maybe we might also want to control that as well. And still works. Okay. So maybe I would like to have this kind of a control as a final shape. Yeah, I like this shape. We could do that by, instead of using point scale transform node, I could use the point wrangle to control the overall shape using another ramp parameter, I guess. And let's see. Scale value is based on the point height. It makes sense. So let's first get the boundary box minimum and maximum positions using get b box. And normalize the height value of the current point positions by using fit minimum height and maximum height and convert it into in between 0 to 1. Now that I can use this value with the CH ramp, okay, And I want to use this curve to control the scale at each point. So this should be the original point position, the scaling. And finally, I am going to create the scaling value by multiplying h by maximum scale. Let's go with 2. Okay. So if it's straight line like this, then everything will become 2, so it'd be multiplied by 2. And I want to scale it on only on x and z plane, so set SC1, SC, like that. Okay, now's the time to control this curve so that I can control the shape. It's not really straightforward how the curve would look like to create like a bowl-like shape. Something like that. Oh yeah. Alright. Slimy. It's already looking interesting. Something like this. How is it? How is this? Yeah, I think I like it. Onigiri-like shape. And let's see if this could still work. Yeah, did. Nice. For regular shape, does this. Yep, it still works, so good. We now can control the overall shape as well. Let's have that as an additional parameter. Okay, that's pretty much it. And let me know if you have any questions. I don't know if there's anybody watching still. But thanks for all the comments and hope you liked it. Okay, I'm gonna bring this shape parameter. Okay, where this should go. So shape, scale, overall shape scale, max overall scale, alright, and for this scale maybe I can make it 4 as a maximum. Oh, what happened? What has happened? Okay. Alright. Looks good. Thank you very much for watching. So far, it took like more than 2 hours, 3 hours to create this one. That was a long stuff. Thank you all for who has been watching this one. Hopefully you enjoyed it. I am going to upload the file as soon as I finish the live stream to the GitHub. The link will be pasted on the description page of this YouTube live stream, and the video is going to be archived so you can watch it anytime, and you can also download the files from the link, which is also being pasted on the Patreon. So if you're interested in this kind of algorithmic shape, I'll be appreciative if you could support me and somehow, but not really necessary if you find it interesting. Okay, thank you very much for watching, and I guess I'll go to sleep right after I posted the file. Okay, that's it. Yeah, I personally satisfied with the shape that I finalized with. Yeah, hopefully you do as well. Good night, and hopefully see you next week with a new topic. Okay.